Okay, so this next bit introduces the other kind of condensation polymer. Again, it's a polyester, but this time the monomer has both of the functional groups on board in the single molecule rather than needing to have two separate ones. So you can see that when this polymerizes, the alcohol group up here and the carboxylic acid group down there are going to condense together and eliminate that water. Like that. So it's not drawn in a very helpful way in terms of visualizing how the chain's going to be built up, but it's probably worth just drawing it on. I mean, you could redraw it, I guess, in a more favourable orientation, but it's probably easier just to keep it like that and realise, right, that hydrogen is going to be lost, and so you're going to get a linker bond like that to the next one, and that OH is going to be lost. And so we're going to get the linker bond onto the next oxygen like that. And then you can just draw the same thing again. And so the chain's going to repeat like that, and so we then have another oxygen. And you know, that's how the polymer's going to repeat. Now, it doesn't actually ask you to draw that out, but sometimes it may be helpful just to do that a little bit, just to convince yourself that you can see how the polymer works. What it does actually ask you to do is to write an equation for the condensation polymerization. So we're going to have n lots of that monomer, which looks like this. And they're going to condense together to give you your repeat unit, which is now just going to have the oxygen on the end with a linker bond like we had in the fragment we drew up here. Now, the thing is, it's a bit messy if you do it like that, so at this point the easiest way to draw that, because otherwise your linker bond's going to sort of stick out the bracket down here, which you kind of could do, but I think it would be neater just to say, right, well, let's just twist that carboxylic acid group round, and then we can do that and say, right, that's now our repeat unit, and that's repeated n times, and each time one of those is added on you get a water, so that will have n waters as well. Okay, so it's relatively straightforward, but it's just because of the way it was drawn, you've got to sort of be able to twist it around in your head a little bit, but do as much as you need to on paper rather than do it in your head if you find that difficult. So this last little bit just makes the point that this compound can actually form two kinds of polymers, because as well as the alcohol group and the carboxylic acid group, which let it form the condensation polymer that we've been looking at, it also has an alkene group, so it can form an addition polymer, and we're just asked to write out two repeat units of that. So if you can see how that's going to work straight away, then fine, just go ahead and write it down, but otherwise the sensible thing to do is probably to just redraw the monomer first of all, just to get clear in your head in that sort of format, because remember, that's the way that makes it very easy to see how the repeat units are going to work. So the first carbon has a hydrogen here, and then a CH2OH, and the other carbon has a methyl group and a carboxylic acid group. Okay, so that's the same compound just drawn out in that format, and if we convert that into a repeat unit, we get the usual thing, that the alkene group now becomes singly bonded carbons with two linker groups. Put the same four groups on each end so that you get that. And then two repeat units means you just connect that up to another one that's exactly the same. So we get this. And there you have your two repeat units, and that's basically it. Okay, and the dog would like to apologise for barking. Okay, so question 5 asks us to draw a repeat unit of the polymer formed from these two monomers. Now the thing is this time that it's making the point that in practice it's much easier to do this polymerization if instead of using a carboxylic acid or a dicarboxylic acid, you use an acyl chloride, because as we know those are much more reactive, and so you can do it without a catalyst and without worrying about the equilibrium involved. So again, it's a condensation reaction when they come together, but this time it will eliminate HCl rather than water. So basically you're going to get a condensation reaction which takes the hydrogen from the alcohol group, as always, and then this time instead of the OH group from a carboxylic acid, it'll take the Cl group from the acyl chloride and just link them together like that. So it's actually going to be fairly straightforward. We're going to get this, and each of those alcohol groups is going to now become a linker oxygen. So that one just links to whatever comes next, but this one we draw in the link which is now going to come to that carbon because we've lost the HCl's in between. So we'll get that. And again down here we've still got the carbonyl group, but we've lost the Cl, and again it's easier just to twist this round a little bit, put the carbonyl group down there, and then we can draw the linker bond out of the end, and that's the repeat unit.